Welcome to the session on gamma distribution. A continuous random variable capital X is said to follow a gamma distribution if its probability density function is given by f of x is equal to 1 by beta raised to alpha into gamma alpha into x raised to alpha minus 1 into e raised to minus x by beta, where x is greater than or equal to 0 and f of x equal to 0 otherwise, where alpha greater than 0 and beta greater than 0 are the parameters of the distribution. We have to verify this f of x defines the PDF. The two conditions for a function f of x to be the probability density function of a continuous random variable capital X is, first one is f of x is greater than or equal to 0 for every values of x, and second condition is integral from minus infinity to infinity f of x dx is equal to 1. These are the two conditions for a function f of x to be a PDF. Here obviously this function is always greater than or equal to 0, because here x greater than 0, alpha greater than 0 and beta also greater than 0. Therefore, this term will become greater than 0. Also, gamma alpha is always greater than 0 and equal to 0 otherwise, means f of x is obviously greater than or equal to 0 for every values of x. Now, we want to verify this second condition, integral from minus infinity to infinity f of x dx is equal to integral from minus infinity to 0. We can split this integral into 2 as integral from minus infinity to 0 f of x dx plus integral from 0 to infinity f of x dx. This is equal to, in this case the function is defined as 0, because for x greater than 0 the non-zero value of function is this. Here integral from minus infinity to 0 means x is less than 0, in which case f of x is defined as 0. Therefore, this integral will become 0 plus integral from 0 to infinity. In this case, the function is defined as 1 by beta raised to alpha into gamma alpha, x raised to alpha minus 1 into e raised to minus x by beta dx. This is equal to evaluate this integral, we use the substitution x by beta is equal to some t. X by beta is equal to t means x is equal to beta t, beta into t, so that dx is equal to b into dt. Here the limits of integrations are 0 and infinity. When x is equal to 0, t is equal to 0, and when x is equal to infinity, t will become infinity. Therefore, the limits of integration are the same. This integral will become integral from 0 to infinity 1 by beta raised to alpha into gamma alpha x raised to alpha minus 1 means beta t raised to alpha minus 1 into e raised to minus x by beta is e raised to minus t. Dx is beta into dt. This is equal to integral from 0 to infinity 1 by beta raised to alpha into gamma alpha. This term can be written as beta raised to alpha minus 1 into t raised to alpha minus 1 e raised to minus t beta dt. This is equal to here b raised to alpha minus 1 into beta raised to alpha minus 1 into beta means beta raised to alpha minus 1 plus 1. That means beta raised to alpha and beta raised to alpha, this beta raised to alpha in the denominator will be cancelled. Therefore, these terms are cancelled. This is equal to this 1 by gamma alpha can be taken outside of the integral because it is a constant independent of t. Therefore, this is equal to 1 by gamma alpha into integral from 0 to infinity t raised to alpha minus 1 into e raised to minus t dt, which is equal to 1 by gamma alpha into this integral is gamma alpha. By the definition of gamma function, it is gamma alpha. For gamma alpha divided by gamma alpha is 1. That means the total PDF, that is the integral from minus infinity to infinity f of x dx is equal to 1. The second condition for a function f of x to be a PDF is also satisfied for this function. Therefore, this function can define a PDF. Now, we have to find the expectation or the arithmetic mean of gamma distribution. Consider a random variable, continuous random variable having the gamma distribution with parameters alpha and beta. Then f of x is this function, and by the definition, arithmetic means simply mean of x, which is equal to expectation of x. We can write the mean of x in terms of expectation. By definition of expectation, it is integral from minus infinity to infinity x into f of x dx. Now, we split this integral into two. This is equal to integral from minus infinity to 0 x into f of x dx plus integral from 0 to infinity f of x into f of x dx. In this case, the value of variation of x is less than 0. Minus infinity to 0 means x is less than 0, in which case the function is defined as 0. Therefore, this first integral will become 0, plus the second integral is integral from 0 to infinity x into f of x is 1 by beta raised to alpha into gamma alpha x raised to alpha minus 1 into e raised to minus x by beta dx. This is equal to integral from 0 to infinity. Here x into x raised to alpha minus 1 means x raised to alpha into 1 by beta raised to alpha into gamma alpha e raised to minus x by beta dx. In order to evaluate this integral, we use the substitution x by beta is equal to t, which gives x is equal to beta into t, so that dx is equal to beta into dt. The limits of integrations are when x is equal to 0, t also equal to 0, and when x is equal to infinity, t will become infinity. Therefore, this is equal to integral from 0 to infinity. X raised to alpha means beta t raised to alpha, beta into t all raised to alpha, into 1 by beta raised to alpha into gamma alpha e raised to minus x by beta is t, e raised to minus t, dx is beta dt. This is equal to, here beta into t all raised to alpha means beta raised to alpha into t raised to alpha. Beta raised to alpha and this beta raised to alpha in the denominator cancelled. The remaining terms are integral from 0 to infinity. Here beta, this beta can be taken outside. Divided by gamma alpha. Gamma alpha is also a constant, therefore beta by gamma alpha can be taken outside into integral from 0 to infinity t raised to alpha into e raised to minus t dt, which is equal to beta divided by gamma alpha into, by the definition of gamma function, this integral is gamma of alpha plus 1. That is mean of x is equal to beta divided by gamma alpha into gamma alpha plus 1. This is equal to beta divided by gamma alpha into, we have the recurrence relation for gamma function, that is gamma of alpha plus 1 is equal to alpha into gamma alpha. This gamma alpha and gamma alpha in the denominator cancelled. This is equal to beta into alpha or alpha into beta. That is the mean of x is product of the parameters alpha and beta. Now we have to find the variance of gamma distribution. In terms of expectation, variance of x is defined as v of x is equal to expectation of x square minus expectation of x the whole square. We have e of x is alpha into beta. Therefore, we have to find e of x square only. By definition of expectation, e of x square is equal to integral from minus infinity to infinity x square into f of x dx. We split this integral minus infinity to infinity into two integrals as integral from minus infinity to 0 x square into f of x dx plus integral from 0 to infinity x square into f of x dx. In this case, the variation of x is less than 0, means function f of x is defined as 0. Therefore, this is equal to this integral will become 0, first integral will become 0, and integral from 0 to infinity x square into f of x is 1 by beta raised to alpha into gamma alpha x raised to alpha minus 1 into e raised to minus x by beta dx. This is equal to integral from 0 to infinity x square into x raised to alpha minus 1 means x raised to alpha plus 1 into 1 by beta raised to alpha gamma alpha e raised to minus x by beta dx. In order to evaluate this integral, as in the previous case, we use the substitution x by beta is equal to t, so that x is equal to beta into t and dx is equal to beta into dt. The limits of integration remains the same. This is equal to x raised to alpha plus 1 means beta t raised to alpha plus 1, that is integral from 0 to infinity beta t all raised to alpha plus 1 into 1 by beta raised to alpha into gamma alpha e raised to x minus x by beta means e raised to minus t dx is beta into dt. This is equal to here beta raised to alpha plus 1 into beta means beta raised to alpha plus 2. In the denominator here is beta raised to alpha. Therefore, beta raised to alpha cancelled. This is equal to integral from 0 to infinity t raised to alpha plus 1 into here this 1 by gamma alpha can be taken outside. Here beta square, that beta square can be taken outside. Therefore, this is equal to beta square by gamma alpha into integral from 0 to infinity t raised to alpha plus 1 e raised to into e raised to minus t dt. This is equal to beta square by gamma alpha into, by definition this is gamma alpha plus 2, which is equal to beta square by gamma alpha into, by the recurrence relation of gamma function, gamma alpha plus 2 can be written as alpha plus 1 into gamma alpha plus 1, which is equal to beta square by gamma alpha into alpha plus 1 into this gamma alpha plus 1 can be written as alpha into gamma alpha. Therefore, gamma alpha and gamma alpha cancelled. The remaining terms are alpha into alpha plus 1 beta square. This is the expectation of x square. Therefore, variance of x is equal to alpha into alpha plus 1 beta square minus expectation of x is alpha beta, e of x whole square means alpha beta square, which is equal to, here we open this bracket, we get alpha into alpha is alpha square into beta square plus alpha into 1 is alpha into beta square minus alpha beta whole square means alpha square beta square, which is equal to alpha square into beta square minus alpha square into beta square is 0. The remaining term is alpha into beta square. That is variance of x for a gamma distribution is alpha into beta square. Therefore, the standard deviation of x is positive square root of the variance of x, that is root of alpha into beta square, which is the standard deviation. Now, we have to find the moment generating function for the gamma distribution. Consider a continuous random variable having gamma distribution with the parameters alpha and beta. Then the corresponding probability density function is this. In terms of expectation, the moment generating function is defined as mxt is equal to, this is the notation, mxt is equal to expectation of e raised to tx. By the definition of expectation, it is integral from minus infinity to infinity e raised to tx into f of x dx. We split this integral into two. One is from minus infinity to 0, integral minus infinity to 0 e raised to tx into f of x dx, plus the second one is integral from 0 to infinity e raised to tx f of x dx. In the first integral, the function is defined as 0 because x is less than 0. Therefore, this is equal to integral from 0 to infinity e raised to tx into f of x is 1 by beta raised to alpha into gamma alpha x raised to alpha minus 1 into e raised to minus x by beta dx. This is equal to integral from 0 to infinity, here e raised to tx into e raised to minus x by beta. We can write this is equal to integral from 0 to infinity 1 by beta raised to alpha into gamma alpha into x raised to alpha minus 1. We combine these two, that is into e raised to minus x is taken outside. The remaining terms are 1 by beta minus t, that is e power minus 1 by beta minus t into x dx. Now, we use this substitution 1 by beta minus t into x is equal to some y, so that x is equal to y divided by 1 by beta minus t, and dx is equal to dy divided by 1 by beta minus t. When x is equal to 0, y is equal to 0, and when x tends to infinity, y also tends to infinity. Therefore, the limits of integrations are the same. This is equal to integral from 0 to infinity 1 by beta raised to alpha into gamma alpha x raised to alpha minus 1 means y divided by 1 by beta minus t all raised to alpha minus 1, that is y raised to alpha minus 1 divided by 1 by beta minus t all raised to alpha minus 1 into e raised to, this is minus y by our substitution, and dx is dy divided by 1 by beta minus t. This is equal to, here integration with respect to y, therefore these terms are constants, that is 1 by beta raised to alpha into gamma alpha into, here in the denominator 1 by beta minus t all raised to alpha minus 1, here is 1 by beta minus t, therefore this these terms will become 1 by beta minus t all raised to alpha into integral from 0 to infinity y raised to alpha minus 1 into e raised to minus y dy. This is equal to 1 by beta raised to alpha into gamma alpha into, here we can write this as 1 minus beta t all divided by beta raised to alpha, integral from this into integral from 0 to infinity. Sorry, by definition of a gamma function, integral from 0 to infinity y raised to alpha minus 1 into e raised to minus y dy is, this is the definition of gamma function, that is here this into gamma alpha. Therefore, this gamma alpha and gamma alpha cancelled. Here beta in the denominator, beta raised to alpha into 1 minus beta t divided by beta all raised to alpha. This means 1 minus beta into t all raised to alpha divided by beta raised to alpha. Therefore, this beta raised to alpha and this beta raised to alpha cancelled. This is equal to 1 by 1 minus beta t all raised to alpha, which is the moment generating function of the gamma distribution. Now, let me conclude this session. In this session, we discussed the arithmetic mean, variance and standard deviation of gamma distribution, and also we derived that the moment generating function is mxt is equal to 1 divided by 1 minus beta into t all raised to alpha. Thank you for watching this class. Have a nice day.